Hi guys, I am looking in the note packet on week 19, day 1, and you should be following along. We're talking about quadratic functions today, and quadratic functions are just polynomial functions whose leading term has a degree of 2, and what that means is your equation might look like this, x squared. Notice that degree is a 2, and whose shape is a parabola. And a parabola is just a U-shaped graph. So if I take a look at the 3 examples down below, we're going to determine which way they open and the intercepts and the vertex. So problem number 1 opens up. And I know that because this U-shaped graph is opening up. The x-intercepts would be where it crosses the x-axis. Now remember, this is your x-axis. And it looks like it's just touching it right here at 0. So my x-intercept would be 0, 0. My y-intercept, this is my y-axis. And again, it's just touching at the origin. So my y-intercept would also be 0, 0. The vertex in an upward-facing parabola is always the lowest point right here. That would be your vertex. So on problem number 1, right here, would be my vertex, and that would also be 0, 0. Let's look at problem 2. Problem 2, I would say, opens down. Now I'm going to look for the x-intercepts. It looks like it's crossing right here, maybe about 1/2, and 1, 2, 3, 4, 5, 6, maybe 7.5. So 1/2 and 7.5, and how I'm going to write it is 0.5, 0. And 7.5, 0. My y-intercept would be where it's crossing the y-axis, and it is a little bit hard to tell on here, so we'll just estimate and say that that's about -2. 0, -2. And then we have to determine what the vertex is. Your vertex, again, is going to be, well, in a downward facing parabola, your vertex is the highest point. So right here on my graph, and it looks like I'm at about 1, 2, 3 over 4 and up 1, 2, 3, 4, 5, 6. So I would estimate that to be 4, 6. Okay, problem number 3. This parabola right here is going to open up. If you notice, though, there are no x-intercepts. This is my x-axis, and it doesn't cross this axis at all. So x-intercepts, none. Y-intercept, again, it's a little bit hard to tell on this graph, but I'm going to do my best to estimate 1, 2, 3, 4, 5, maybe 6. And we're just estimating based off of the graph we have pictured. 0, 6. My vertex is going to be this lowest point right here. I can pretty clearly see that it is -1, and then it looks like it's about up 2. So right here, and it is -1, +2. So that's how we can do it if we're looking at a graph. Now, a quadratic function can be expressed multiple ways. And these are the 2 ways that we're going to talk about in here. The first one's called transformation or vertex form. And transformation or vertex form looks like this. We call it that because when it's in that form, we can find the vertex. The vertex is going to be h, k. The other form, and we will talk about that in a moment, but the other form is called polynomial form. And polynomial form is going to look like this. So let's talk about why we would use the 2 different forms and when they're helpful. Starting with transformation or vertex form. This form right here is most useful for finding the vertex because the vertex is just going to be h, k. So h, k. We are going to have to find the y-intercept, and just like back in Algebra 1, to find a y-intercept, we sub-zero in for x. And to find an x-intercept, we sub-zero in for y. So let's take a look at our first example. Here's our function. It's in vertex form for us. And so the first thing I want us to do is find the vertex. Well, when it's in vertex form, the vertex is h, which is 3, comma k, which is -4. Notice I only switch the sign if it's inside the parentheses. Within the parentheses, I switch this over to a +3, and out here I'm keeping this as a -4. Okay, the other things that we're going to have to find are x-intercept and y-intercept. So x-intercept, we'll have to do a little bit of work. So we're going to go into our function, which was this. Let me rewrite it. Y equals x minus 3 squared minus 4. And to find an x-intercept, I'm going to put 0 in for y. So let's put that in and solve this equation. 0. First thing I'm going to do is add 4 to both sides. Then I'm going to take the square root of both sides. Please don't forget when you take the square root, you need to do plus or minus. So I'm going to have, plus or minus 2 equals x minus 3. And then I'm going to add 3 to both sides. And I have 3 plus or minus 2 equals x. Now, I'm not going to leave it like that. I'm going to use the plus. 3 plus 2 is 5. So one of my intercepts is 5, comma 0. And then I'll do 3 minus 2, which is 1, and that's my other x-intercept. Now we have to find the y-intercept. That one will be a little bit easier. Y-intercept, I'm going to go into my equation. This is the original equation. And for a y-intercept, in for x, I'm going to substitute in 0. So y equals, just put 0 in for x, and simplify. -3 squared is 9. So I have 9 minus 4, y equals 5. And then I'm going to write it as an ordered pair. So 0, comma 5. So now I've got some important points. I'm going to come over to my graph and draw it in. I am going to draw in an xy axis because this graph did not come with one. And I'll start off by plotting my vertex. 3, -4. Plot your x-intercepts. And plot your y-intercept. Feel free to press pause if I'm moving too quickly. And then connect up into a U-shaped graph, and you've graphed your parabola. Okay, that was when it was given in vertex form. Let's try on the next page one that is given to us in polynomial form. So this one's given to us in polynomial form. This form is most useful for finding the y-intercept. That's going to be the easiest thing to do. So again, I'm going to ask you to find 3 things. I'm going to ask for the vertex. I'm going to ask for x-intercepts. And I'm going to ask for y-intercepts. Now remember, I said that y-intercepts were going to be the easiest ones to find. Okay, so let's do that first. Here's my equation. To find a y-intercept, I just go into this equation, and where I see x, I substitute in 0. And I get 3. And so my y-intercept will be 0, comma 3. To find my x-intercept, I am going to go into this equation. And where I see y, I'm going to substitute in 0. Now to solve this is going to be a factoring problem. So I'm going to factor and set each factor equal to 0. And actually, unfortunately, this thing does not factor. You know what? there's actually a typo on my paper. It's not going to be a big deal right now, but I would like for us to change in the original problem, this plus right here, change that to a minus, please. This right here, I'm sorry, change the 3 to a -3. That's what needs to be negative. This right here was a typo. And so I actually need to change it over here to a minus, change it over here to a minus, which will make this -3. This will make it factor a whole lot nicer now. Okay. So if I have this trinomial that I'm trying to factor, I need my numbers to multiply to -3 and add up to +2. So they are going to be x plus 3 and x minus 1. Just set each equal to 0, -3 and 1. And because they're x-intercepts, I have to write them as ordered pairs. Okay, now to find your vertex, and you might remember this from Algebra 2, this is the formula that I'm going to use to find the x-coordinate of my vertex, -b over 2a. Okay, and that's the formula to find the x-coordinate of my vertex. So I'm just going to go into y equal, I'm going to take a look at my equation, I should say. And as a refresher, this number right here is a, this is b, this is c. So take a look at that and see if we can figure out what -b over 2a is. Okay? -b over 2a. Then simplify that, and that's going to be your x-coordinate. So x equals, and that's going to go to -1. So my x-coordinate of my vertex is -1. Now, what's my y-coordinate going to be? To find my y-coordinate, I go back into my equation and plug in -1 for x. -1 squared, and just simplify that, and I get -4. All right, let's go over to our graph, and let's put our axis on. And now let's start plotting all of our points. So we can start with our vertex if we want. Do our x-intercepts. Our y-intercept. And then connect up as best as you can. It should look like a U-shaped graph, like a parabola. So we just practiced graphing when it was in vertex form, and then we practiced graphing when it was in polynomial form. Okay, we always have to find the same things, but how we find the vertex is a little bit different on the way that each one is going to be set up. All right, so how are we going to convert between the 2 points? Or between the 2 forms? So this right here is in polynomial form. And look at the problems that I gave you. They're not in polynomial form. We need to convert them into polynomial form. So to convert into polynomial form, we're just going to multiply everything out and simplify as much as possible until it looks like this. So in problem number 1, I have f of x equals 2. Now the x minus 3 is squared, so I'm going to write it twice. And then I'm going to FOIL it. I'm going to deal with the 2 when I'm done. So when I FOIL this, outer, inner, just FOIL it out. Distribute the 2. and just simplify everything when you're done. So my final answer would look like y equals, or f of x equals, either way is okay to write. F of x equals 2x squared. These guys are like terms, so negative 12x. And then on the end, plus 19. Okay, and that would be in polynomial form. Let's try number 2. So number 2, you have a choice here. You do need to multiply it all out. I'm going to choose to FOIL this first and then distribute the negative 3. So keep that negative 3 out front and FOIL. Can distribute the negative 3. And then just combine up like terms, and this will be your answer. Negative 3x squared minus 9x plus 12. Okay, so both of those that we just did brought us into polynomial form. Both of my answers look like that polynomial form. Now it's a little bit more difficult to go the other way. So in the next set of problems, we're going to convert into vertex form. We'll have to complete the square, which is something that you were taught in Algebra 2, but I'll refresh your memory on it. So to put it into that vertex form, we are going to start with my f of x equals. I'm going to write down the two terms that have the x's right next to each other. X squared minus 6x. But then I'm going to say plus blank. I'm going to add some number in. I also have plus 2 because that came with the problem. Now, we all know that we are not allowed to just randomly add a number in. That'll change my problem. So if I'm going to add a number in, I also need to subtract it out when I'm done. So whatever I add, I'm going to subtract back out. And then to see how to complete the square, if you forgot the formula for it, to complete the square, the formula is you take b, you cut it in half, and you square it. So in this particular problem, b is negative 6. So negative 6 cut in half and squared. And when I do that, I get negative 3 squared is 9. So I'm going to add 9, then I'm going to take back away 9. Okay, why? Why did we just do that? The reason that we did that is these 3 terms will now factor. These 3 will always now factor. And not only will they factor, but they're going to factor into the same factor twice. So instead of writing it twice, we're just going to say that whatever the factor is, squared. Now I'm wondering what numbers multiply to 9 and add up to negative 6. And those numbers are going to be negative 3 and negative 3. So x minus 3 quantity squared. A little hint, if you're having trouble factoring that, is if you're wondering what's going to go right here, it's always half of this middle number. So if b is negative 6, negative 3 goes here. All right, don't forget we still have these guys out on the end. 2 minus 9 is negative 7. So minus 7 goes right here. And now that's in vertex form. If I asked you at this point, what is the vertex? Hopefully you could look at this and say, okay, the vertex is going to be h, comma, k. So the vertex would be positive 3, negative 7. Okay, let's try number 4. We have to put it into vertex form. So we're going to need to complete the square. F of x equals x squared plus 4x plus blank minus 3, And then remember, if we added in something, we have to subtract it back out. So what number are we going to add in and then subtract out? Well, it's b cut in half squared. 4 cut in half is 2, and 2 squared is 4. So 4 is that number we're going to add and then subtract back out. The reason that we complete the square is so that these first 3 terms can now factor. And so they're always going to factor into the same thing twice. Remember the shortcut? To figure out what goes here in my factor, it's always half of b. Well, b is 4, so it's going to be plus 2. Don't forget these ones on the end. -3 minus 4 is -7. And that's in vertex form. If we looked at that and I said, what's the vertex of this problem? Hopefully you can look and see it's HK. So it is -2, -7. And last up, let's complete the square. Take b, cut it in half and square it. It's going to be a 16. Let's factor. It's going to factor into x minus 4, quantity squared. On the end, I still have 1 minus 16, which is -15. Okay, so we just practiced converting both ways. We converted into polynomial form and then we converted into vertex form. All right, there is some practice here, and I would like for you to try these 7 problems. Try them on your own. Follow the steps that we did above. Make sure you're following directions. On problems 1, 2, and 3, you are supposed to graph when you're done. So on problems 1, 2, and 3, you're going to need to draw in your own graph. And then down at the bottom, you're going to work on some conversions. And when you're finished with this, please take a scan or a picture of this page and upload it into Schoology.